Today our experiment is frequency response of low pass and high pass RC filters. Here the circuit diagram is here. Here we are using function generator and one oscilloscope, and we need components resistor 10 kilo ohms and capacitor 0.01 microfarads. For this we need NILVS kit, inbuilt software system. So now coming to the circuit diagram. We have 10 kilo ohm resistor, and in series with capacitor 0.01 microfarads. For this we need to give function generator as input. Positive is given to the resistor, negative is given to the ground. Here DC power supply ground is given to here. I take here as common ground for all this. Next, channel 0 is given to them to see the input signal given to input. Okay, function generator is given to the input and the ground is connected here, and the channel 0 is connected input for seeing the output oscilloscope, and channel 1 is connected to output. Let us see it in the oscilloscope. For here it is low pass filter. The main function of this low pass filter is it is allowing only low frequency signals. Okay, for this we need to give 10 volts peak to peak here, and giving very low frequency 100 hertz here. And hertz frequency I am giving here 10 volts peak to peak. Now we check here, peak to peak voltage is 10 volts and the output peak to peak voltage is 9.98 volts. Here the channel 0 is input and channel 1 is the output. Okay, here the 100 hertz frequency low pass filter can allow 100 frequency. Next, now we can change it to 1 kilohertz. 1000 hertz equals to 1 kilohertz. Now run this. 1 kilohertz frequency also it is allowed, and frequency is 1 kilohertz we are getting output, and peak to peak voltage input is 10 volts peak to peak and the output is 8.48. Next, we can give 10 kilohertz. 10 kilohertz frequency here applied, 10 volts peak to peak, and here the input voltage is 9.3 volts and the output is negligible, 1 volt only. Here the 10 kilohertz frequency is high frequency. Here the main function we are operating is low pass filter, it allows only low frequencies. We are applying here 10 kilohertz, so it is the high frequency. Then the output will get only 1 volt of amplitude. Then we can apply 20 kilohertz. So here the complete DC signal is not allowed at the output. Here the input is here and the output is in millivolts only, that is negligible voltage. For low pass, from this input and output voltages we can draw this graph. Here it is the low pass filter, it allows only low frequencies. In the sense, from this input voltage and output voltages we can calculate the gain by this formula 20 log V out by V in. So from this gain and frequency we can plot a graph. From this gain and frequency we can plot the graph. Gain is in y axis and the frequency in the x axis. Here one thing I have to tell, below minus 3 dB frequency the low pass filter can't allow the frequencies, shows above the above the 3 dB frequencies it can allow pass band, and below 3 dB frequencies it can stop the signal. Okay, now coming to the high pass filter. In this only the difference is we can replace capacitor and resistor places and we can get the high pass filter. Coming to the circuit diagram, simply we can change these places. Now this is the high pass filter. High pass filter in the sense only it allows high frequency signals and blocks low frequency signals. In previous case we are using low pass filter, it allows only low frequency signals and blocks high frequency signal. So this is both are opposite to each other. For this we need to give it blocks low frequencies. Yeah, once you will get the difference. So see here once, here we are applying 20 kilohertz frequency, 10 volts peak to peak. Yeah, see here we are getting output and input are same, frequency are the same. From this we can say this it allows high frequency signal. For example, I will give here 1 kilohertz frequency. See here where the input voltage is 10 volts and the peak to peak output voltage is 5 volts. In the sense the low frequency is avoided by somewhat, and then again I will give you 100 hertz. See here the input voltage is 10 volts, but the output is approximately equals to DC, in the sense 832 millivolts. From this is the low frequency. For this reason the high pass filter only allows high frequency signals, blocks the low frequency signals. Here the high frequency waveform is below 3 dB it can allow, below 3 dB frequency gain it can allow the high frequency, and above 3 dB it can blocks the above, it can allows the only the above 3 dB frequencies and blocks the 3 dB frequencies. Okay, thank you.